This is objective 32. We are going to move on to solving systems by graphing. And if you look, okay, everybody sees we were in slope, and now we are moving to systems. So we only have a few left to go. Okay, we will probably be in systems for about 4 days, and then I'll be ready for a test. We're going to learn several different ways to solve a system. Why do you need to learn multiple ways? If you want to be good at something, you need to know multiple ways to do it. So depending on, and then you can choose. Some of you will like this way. I'm also going to teach substitution to you, and then I'm also going to show you by elimination. Okay, I'll be honest with you, a lot of people like graphing because you'll feel comfortable with it, and it's a review of what we've been doing. Okay, substitution, I might have like 2 that like that. Okay, but you need to know how to substitute and the concept of it, especially for when you get into geometry and algebra 2. So it's good to know. A lot of you will also like elimination. Okay, so substitution, there'll be just a couple, but then when we hit elimination, you'll be like, oh man, that's easy. And so you'll really like elimination too. So most popular ways I would say are graphing and elimination. Substitution's kind of in the middle. Okay, then we're going to look at word problems with systems. And then you'll be ready for a test. So if I can do 1 each day, that would put you at a test next Friday. Okay, if I do 1 a day, then I do substitution on Tuesday, then I can do elimination on Wednesday, word problems and review on Thursday, and then test on Friday. Okay. Someone tell me what a system is. If you have a system of anything.
Something that works.
Something that works. Is it just one thing, or is it? It's multiple things working together, right?
Yeah.
Yes. So when we have a system of equations, what do you think? More than one. We are solving 2 or more equations at one time. Okay? 2 or more equations at one time. In Algebra 1, we're just going to be looking at 2. You're not going to see 3 and 4 and 5 equations at one time. But, that's what a system is. Okay? And you need to know, like when you get a problem on the SOL and you see 2 equations together, you'd be like, oh, that's a system. I can graph it. I can solve it by substitution. I can solve it by elimination. You need to know what you're looking at. Okay? Any questions on that? Okay. All right. There are going to be 3 possible answers. Okay? First of all, if we graph the first equation, a linear equation, what will the shape look like? What will it look like? You've graphed equations before. What did you draw me yesterday? Did you draw me circles? No, you drew me lines. Okay, so we graphed the first one. How do you think we're going to graph? Using what? Y equals mx plus b. Do we know how to graph in y equals mx plus b? Yep. Okay, so we're going to use that review of what we just did. So you graph the first one. Tell me, where are all the answers? Where are all the solutions on that line? On that line, right? Remember, I told you, all the answers are the x's and y's. That is a point that when I plug that x and that y in, what happens to the 2 sides? They become equal or balanced. Okay, what if I plugged this point in? Everybody agree that's a point? It has an x and it has a y. If I take that x and plug it in, and I take that y and plug it into the equation, and I work the 2 sides out, the 2 sides will be equal. It might say something like 5 is equal to 5. Is that equal? Or it might say 29 is equal to 29. The 2 sides turn out to be equal. What if I plug this point in? Everybody agree that's a point? It has an x, has a y. If I take that x and I take that y and I plug it in, what happens to the 2 sides? They become equal or balanced. That's what makes the equation work. Okay, well then let's say we have a second line. Where are all the answers to that line? On that line. Okay, if I plug that point in, plug the x in, plug the y in, work the 2 sides out, what will happen? It'll be equal or balanced. What if I take that point and plug it in? It'll be equal. Okay, so the question, if I'm doing two at one time, is where's the point that works for the black line and the red line? Where it intersects. So we are looking for this point. Everybody agree? This point right here, would it work if I plugged it into the black line equation?
Yeah.
Would it work if I plugged it into the red line equation?
Yeah.
Yes. So you are looking for the x and the y that works for both. So in this case, you would have one answer, 1 point. Okay? And I was very impressed yesterday on your extra credit. When I asked for 2 points this time, people gave me 2 points. So I appreciate that. Okay? All right. What if I have one that looks like that? Where's all the answers for that line? On that line. Okay. And then if I have one that looks like that, where are all the answers for that line? On that line. So where's the point that works for the blue line and the red line? There's not any that works for both, right? So the answer is no solution. Okay. And what kind of lines are they? Parallel lines. Okay. What can you tell me about parallel lines?
They never intersect.
They never intersect, and they also have the same slope. Very good. They rise and run together, so they never intersect. Okay? Y'all with me? Okay. All right. What if you have one that looks like that? All the answers are on that line, and then you graph another one, and it happens to be on top of it, which basically means what? The two equations are the same, exactly the same. So where's the point or points that work for the green line and the blue line? So how many are there? A bunch. That one and 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 that one. Everybody agree? All of those points. And these lines extend to infinity, right? So the answer would be many solutions. So either they cross at one place and you have an answer, one answer, or they're parallel and they don't cross, and so there's not a point that works for both, and so the answer is no solution, or they're smack dab on top of each other and the answer would be many solutions. Those are going to be your three options. Any questions on that? Okay. So here's example 1. What form? We're going to graph each one of them. I'm going to graph the top one. Everybody agree this is a system, by the way? What makes it a system? There's 2 of them, 2 at one time. Okay. So I'm going to graph the top one in blue. What form is it in? Y equals mx plus b. Again, I'm going to give you your test back today. Some of you still struggle graphing, so pay attention. But I would say pretty much 90% of you got it, so I was impressed. So where's my starting point, Haley? Where? Nope. Your starting point is always your y-intercept. So it's where it crosses this line right here. And so it would be down 3. It's always either up or down, your starting point. Okay? From there, what's my slope, JT? 2 what? Over 1. So where am I traveling in my elevator? Up 2? Over right 1. Positive 2, positive 1. Positive 2, positive 1. And I would, if I were you, okay, you're going to need to put a lot of points on here, okay? The more points you have, the what? Straighter your line's going to be, okay? And everybody look at me for a second. What if you don't, what if you only put a couple points and you got your first line here? What if your second line, what if you draw it and it's a little crooked and it intersects here when it should intersect here? Is that going to affect whether your line's straight or not? Is that going to affect your answer? Yes. So I encourage you, put lots of points on here. You want it not just straight, you want it super straight. Okay? So I could also go down 2 and left 1, down 2, left 1, down 2, left 1. So there's your first line. Okay? I'm going to graph the second one in red. Haley, where's my starting point? Where am I going? Nope. Remember I said it's on this line right here, so it's either up or down. Always. Down 1. Okay, and then my slope is 1. Where am I traveling? Up 1? That's it? And right 1, because it's 1 over 1. It's always got to be in fraction form. Up 1 over 1. Aha! Why do I say aha? Because that's my point of intersection, okay? But I'm going to go ahead and make this super straight so it looks nice, okay? Now, am I done?
Yeah.
Nope. You hadn't told me the answer. You got to tell me where it intersects. I see the picture, but I don't know if you know what's the answer or not. Somebody tell me what the answer is? Over 2 and up 1. Again, when you name a point, you go right or left, and then you go into the air. Down the runway, and then in the air. So here's your answer. Now, tell me. I'm going to go back to my blue equation. What does that tell me that my answer is 2, 1? It means when I plug in 2 for x, and I plug in, so I'm going to plug 2 in for x, and when I plug 1 in for y, I'm going to work the two sides out. What should happen? It should be equal. It should work. Okay, does that make sense? This is 4 minus 3, and what is 4 minus 3? Are they equal? Does it work? Check, check. Okay, let's try the second one. Y equals x minus 1. If I plug the 2 in for x and the 1 in for y, what is 2 minus 1? Does it work? Check, check. It makes it work. Makes both equations work. Okay, does that make sense? Yep. Will it always say 1 equals 1? No, it might say
17 equals 17.
it might say 17 equals 17. It's just whatever it comes out to be, the two sides should be equal or balanced because it's an equation. Okay? That's what equation means, equal. Okay? All right. You want to take a minute and graph both of these and see what you can come up with? Okay, take a minute and graph each one, and then I'll graph them. Let's make sure you remember how to graph correctly. Oh, man. 3. Okay. I'm going to have to regraph these. All right. The first one I'm going to graph in blue. I'm going to start at up 5. And then from there, 1, 2, 3, 4, 5, I'm going to travel up 1 and over 1. Okay? Just put lots and lots of points. Okay? And then the second one I'm going to start at?
-4.
No. 0. This is plus 0. So I'm going to start at the origin. And I'm going to travel where?
Down 4.
Down 4. 1, 2, 3, 4. Right 1, because it's 4 over 1. Now here, what's the problem? I'm traveling away from my line, and that's a problem. It's like me riding bumper cars. I am the person that's running from everybody in bumper cars, right? Don't hit me, don't hit me, don't hit me. Well, here's the thing. We want this line, this red line, to hit the blue line. So you need to be, how many people are this? You're the person that's running after everybody trying to crash into them. Yeah, okay. Really, Jessie? She's like, yeah. How many are like me? You're the one that's running from, am I the only one? Oh, that's such a travesty. Okay, here we go. So instead of running away from the line, you just need to reverse it and go up. Bingo. There you hit it. Okay? And so, where's my answer? -1, up 4. Now, I'm not going to waste time, but what would happen if you plugged this x and this y into those equations? they would come out equal. So if you're wanting a way to double check yourself, that would be it. Okay, you can plug them in, okay, and make sure that they come out to be equal. Did everybody get these lines okay? Do you know what else? Can I show you something real quick? I've had people before graph the lines, and they graph like here. And so they graph this itty bitty line right here. And then I caution you, and then they graph like other lines like over here. And then you know what they tell me? They say no solution. They tell me that those lines don't intersect. So what would you tell that person? Well, what do you got to do? Make longer lines. So you know eventually if I kept going, you follow? Bingo. You would bam cross. Okay? So how many of you draw really short lines? Because I saw some on the test yesterday. Okay? Please make sure on these, you're going to want to extend your lines, and so put lots of points on there so you can see where they cross. Okay? And the only time it's going to be no solution is if they are parallel. Okay? All right? Where am I going to start for the top one up here? Up 2. Then where am I traveling? What's the slope? Down 1, right 2. Remember, a negative is only negative in one of them, right? Down 1, right 2. Down 1, right 2. Or you can go up 1 and left 2. Up 1 and left 2. Up 1 and left 2. Okay? Does this make sense? I caution you, for the most part, y'all did very well. How many double checked and like triple checked your test yesterday for careless errors? How many found careless errors? Like while you were working them out? Yeah. So a couple of us did. So Taylor found careless errors and went back and fixed it and ended up with 105. I had some people still on a negative slope still draw me lines that went up and it didn't match. Okay? Just cautious, careful, conscientious. I'm going to draw the bottom one in green. Where's my starting point, Haley? Down 3. Very good. 2, 3. And then where am I traveling from there? Down 3, right. Well, again, I'm traveling away. I need to go and hit that line. So I need to travel towards it. Up 3, left 1. Up 3, left 1. So there's your line. Okay. Where's the point where they cross? Negative 2, 3. Very good, Bennett. Okay. So again, how can you check yourself? You take your X and your Y and plug them in and make sure that the two sides are equal. Okay. Everybody okay? Moving right along. Y'all okay with that? Yep. Pretty simple. All right. What's different about this one? What do you mean it's backwards? Hey, it's switched around. What form is that in? It's in standard. It's AX plus BY equals C. Okay? So, what could you do? Could you graph from standard? You could plug in zeros and find your X and Y intercepts. How many did that on the quiz yesterday, or the test yesterday? Plugged in zeros. Now, you're more than welcome to do that, but how many, the rest of us, rearranged it to Y equals MX plus B and graphed it? So that's probably going to be the way we go. Okay, but if you can remember the whole plug-in zero thing, yeah, do that. Because I think that's easy. Okay, but for the most of us, we are going to take this and rearrange it. I'm going to do the first one for you. We move the X over. What happens to it? Change it to a negative, and then what? Divide by 4 here, here, and here. So Y equals negative 3/4 X plus 3. Okay? And so I can graph that line. Where is my starting point, AJ? Where? What direction do I go? Up 3. Good. 1, 2, 3. And then where am I traveling? Jake, where am I traveling? Down 3 and right 4. Very good. Okay. Down 3, 3, right 4. Again, put lots and lots of points on here. 1, 2, 3. So you extend your lines. You don't want those little short lines because you won't see the intersection. And so there's your first line. Take a minute. Can you rearrange the second line? Yeah, so take a minute and rearrange it. Before you graph it, guys, just rearrange it. And then let's check to make sure you rearranged it correctly. Did everybody get y equals negative 1/2 x plus 2?
Yeah.
Yes? Okay. So from there, my starting point is up 2, and then I'm going to go down 1, right 2, down 1, ba-bam, down 1, right 2, down 1, right 2. And so where is my point of intersection? 4, 0. Right 4, up or down 0. And again, how can you check yourself? You can take the 4, plug it in for the x. You can take the 0, plug it in for the y. Make sure that the two sides are equal. Okay? What should this side work out to be equal to? No, this should be equal to 12. What should this side be equal to? 8. It should say 8 is equal to 8. Does that make sense? Okay. All right. What do you think about this one? It's going to be many solutions?
It's going to be the no solution.
How do you know it's a no solution?
Because it's the same thing.
First, almost. It's not quite the same thing. Our starting point's different?
Yeah.
So I'm starting 1 at positive 1, and I'm starting 1 at negative 1. And then from there, I am rising and running at the same rate. So what kind of lines will they be? So if you can see that, like I can look at this and say, hey, that's the same slope. If they're the same slope, but yet two different starting points, I know they're going to be parallel. But let's graph them just to make sure. Okay. My top one, I'm going to go up 1, and then I'm going to travel down 2, right 1, down 2, right 1, down 2, right 1, 2, right 1. Okay, so there's your first one. And then the second one I'm going to graph in black. I'm going to start at negative 1, and then I'm going to travel the same rate. Down 2, right 1, down 2, right 1, down 2, right 1, up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. So where do they cross?
Nowhere.
Nowhere. So the answer is no solution. Another way, most of the time in Algebra 1 you see no solution. Another way you can write that is an empty set. It's a circle with a line through it. Okay? An empty set. It means the set of your answers, the set of answers is empty. There's none there. Okay? Any questions on no solution? Okay. All right. And so as predictable as I am, I bet the next one is many solutions. Why don't you take a minute and graph these? Do you have to rearrange both?
No.
No, just one. Which one?
2x plus 4y equals 8.
All right. So take a minute and rearrange 2x plus 4y equals 8. Sure, because in like 6 weeks when you are doing your practice SOLs and you don't remember, you might want to go back to your notes and look. I take this and I rearrange it, this moves over, and it becomes a negative 2x plus 8. And if I divide by 4, this becomes y equals negative 1/2 x plus 2. So what do you know about this and this? They're the exact same thing. So if you graph one of them, up 2, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, or up and left, up and left, up and left. So there's your first line. Let's graph the second one. It's the same thing, so it's going to be the same exact points. So where's the points where they intersect? Everywhere on the line. Okay, so the answer is many solutions. Okay, another word you might hear is infinitely many solutions. Infinitely means it goes for ever. Okay, there's lots and lots of solutions. Any questions? Pretty simple? Okay. Would you like to see how to put these in the calculator and check yourself?
Yes.
Yes. So, if you will get your calculators out, we'll take a look at a couple of these.
Sounds good. Are your day been so far?
Just fine. All right, here we go. Don't want that. X that out. Okay. Let's just take a minute. Let's go back to example 1. What's the answer to example 1? 2, 1. Okay, so here we go. First of all, if they're in y equals, the only way you can put them in the calculator is if they're in y equals. Do you see why y equals mx plus b is so popular? Because that's the only way you can get it in the calculator, and that's what a lot of people want to do. So we're going to be talking about mx plus b from here on out. Okay? So I'm going to put in 2x minus 3. Make sure you don't put the negative 3. We read it as a minus, so you got to put the minus sign. Okay? And then on the bottom, we're going to put in x minus 1. Any questions on that? Okay, now we're going to hit graph. And you should see your first line, and you should see your second line. Whoa! No, I'm not done. The calculator right now, can you really see where it's crossing?
Yeah.
I mean, you see it, but do you know? Could you tell me exactly how many over and how many up? You put x negative 1, not x minus 1. Okay. This is good. Make sure everybody's putting it in. If you're not getting it, let me know. But from here, and you can ask your neighbor if you need help, or I can help you. You got it? Okay. So as you read it, that's how you put it in. Okay. From here, we can even get the calculator to tell us the intersection. Does everybody see calc above trace?
Yeah.
So we're going to go second calc. We're going to calculate. Now, which one do you think we're going to calculate?
Intersect.
We're going to calculate the intersection. So you're going to have to press enter 4 times or 3 times. Enter gives you the first curve. It says, hey, here's the first line. And then enter again gives you the second line. Hey, here's the second line. Hit enter again. It says, would you like us to take a guess? Sure, why not, right? And if you hit enter a 4th time, there's the intersection. X is 2 and Y is 1. Okay? So you have to go second calc 5, enter, 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 enter. It depends on if you hit enter or if you just hit 5. If you hit 5, then you hit enter 3 times. If you hit enter, then you got to hit enter 4 times. Okay? Here we go. Ready? Second trace, second calc. Now you can just, we want choice number 5. So if you hit the number 5, then you hit enter 3 times. It says first curve, enter, second curve, enter, take a guess, enter, and then it gives you the intersection. Okay? Well, if you put it in wrong, Okay, let's look at another one. Okay, let's go to example 2. Let's put this in, go back to y equals, clear this out, and clear this out, and you're going to put in x plus 5. And then you're going to put in, now this time do I put minus 4x or do I put negative 4x? How do I read it? Negative 4x. So you got to hit the negative button, negative 4x. And then you're going to hit graph. There's your first line. There's your second line. Now, does that look like your picture from example 2?
Yes.
Yes.
Yes, you can check the picture. Then if you want to check the point, you can go second calc. And if you arrow down, you can hit choice 5 or you can arrow down and hit enter. You're going to hit enter, 2, 3, 4.
-1.
X is -1, Y is 4. Isn't that pretty nifty?
Yes.
Okay. Now, what if I wanted to put example 4 in the calculator?
You gotta switch it around first.
You got to switch it around first. You can't put it in unless it's in
Y equals
y equals. Let me caution you when you're putting these in, just a reminder. Actually, let me do example 3 since it's already there for me. How do I put in -1/2 x?
Parentheses, 1.
You got to put parentheses around. If you don't put parentheses around the fraction, it won't work. So, parentheses, -1 divided by 2, close your parentheses, x, and then hit plus 2. And then down below, you hit -3 x minus 3. Okay? Hit graph, and then it'll work for you. Okay? And then to get the intersection, you go second calc, intersect, enter, 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 enter. Okay? Questions? So I've given you 2 ways to check. I'm going to have you graph your classwork by hand. I want you to make sure you remember how to graph. Make sure you remember what slope is and what your intersect is. And then from there, I want you to check it. You can check it by plugging in the x and plugging in the y, making sure the 2 sides are equal, or you can check it in the calculator by plugging it in and going second calc, intersect, enter, 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 enter.